Hi, everybody. Today we are going to be finishing our unit on solving quadratic equations using the quadratic formula. And I wanted to bring a guest today, Daisy. She is way too busy looking at the ball and looking sad. Daisy is my new pup, and she's very, very sweet and very, very snuggly. So she is our guest today, even though she is not looking at the camera and instead just staring at her pink hippo toy. So, the goal with solving quadratic equations is to find the solutions of a quadratic function. Now, solutions is a pretty vague term, but if we want to know exactly what the solutions are, what we mean by that word, we are looking for the x-intercepts. So where our quadratic function crosses the x-axis. That's what we mean by solutions. We can also use the words zeros and roots to describe those solutions. They all mean the same thing. In order to solve quadratic equations using any strategy, the equation must be equal to 0. If it's not equal to 0, we have to make it equal to 0. So in this case, we have x squared plus 4x equals 6. Well, that doesn't equal 0. So to turn this 6 into a 0, we have to subtract 6 from both sides. And we get x squared plus 4x minus 6 equals 0. Now, there's two strategies we've talked about so far. There's factoring and the quadratic formula. Both of these strategies will come up with the same answers, but we use them at different times because sometimes one will be easier than the other. We're going to use the factoring strategy if the quadratic is factorable. So that means if we can find that pair of magic numbers that multiplies to 18 and adds to -9. So we have our multiplying number and our adding number, and we need to find that pair of magic numbers. If we can, we're going to use the factoring strategy. In this example, the magic numbers that multiply to 18 and add to -9 are -3 and -6. So to factor, we will have x minus 6 and x minus 3 equals 0. Then we can set each binomial equal to 0 using the zero product property, which says that if the answer to a multiplication problem is 0, at least one of the factors must also be equal to 0. X minus 6 equals 0 and x minus 3 equals 0. Add 6 on both sides and add 3 on both sides, and we get x equals 6 and x equals 3. The other strategy we have to use is the quadratic formula. We can use this to solve for x if the quadratic is prime or hard to factor, meaning that maybe there isn't a pair of magic numbers that multiplies to our multiplying number and adds to our adding number. In this case, we're going to make sure that the quadratic is written in standard form, ax squared minus bx or plus bx plus c. We're going to identify our a, b, and c, and we are going to plug those values into the quadratic formula. So we have x equals -b, a negative of -12 is positive 12, plus or minus the square root of b squared, so -12 squared, minus 4ac, a is 6, c is 1, all over 2a, 2 times 6. So the next thing we're going to do is deal with our multiplication and our squaring. X equals 12 plus or minus, well, -12 squared is 144. 4 times 6 times 1 is 24, and 2 times 6 is 12. Then we're going to subtract or add inside that square root sign. So 144 minus 24 is 120. So x equals 12 plus or minus the square root of 120 over 12. The square root of 120 is 10.954. From there, we're going to make two equations, one with a plus, one with a minus. That takes up for this plus or minus at this step, and then we'll simplify. 12 plus 10.954 over 12 is 1.91. 12 minus 10.954 over 12 is 0.09. And these are our two values of x. Again, when we are finding the solutions, we are looking for the x-intercepts. Our equation must be equal to 0 to solve no matter which strategy that we are using. And we're going to use factoring if the quadratic is factorable, and we're going to use the quadratic formula if the quadratic is prime. I hope you got a lot out of this video. Good luck on your assessment, and I'll see you next time.